Hello everyone. Let's take a look at our next problem. Evaluate the integral of 1 over the square root of e to the x minus 1. Okay, so my first instinct here immediately was I have no idea what to do, but then very quickly I realized that the denominator, the thing inside the square root sign, can be written as a it can be written as a difference of squares. Does that actually help though? Does that help? Well, I have e to the x minus 1. This is e to the x over 2 plus 1 times e to the x over 2 minus 1. Maybe another thing I could do is factor out an e to the x from the denominator to set up some sort of substitution. Yeah, maybe, okay, hold on. This is like, Well, what if I just do the substitution u equals e to the x? It's not going to be a straightforward substitution because we're missing another exponential in the integrand. But so, you know, we could write this, we could say that du is equal to u dx. So dx is du over u. And so I have the integral of my thing here, dx. This is equal to the integral of 1 over u minus 1 times du over u. Does this help? What if I, hold on. This is kind of a really weird one. Okay, let's try something. Let's try something like this doesn't look like it's going to help much at all either. I almost feel like there might be a trig substitution we could make here at this step. Is there what if I let u squared equal e to the x, 2u du is equal to e to the x dx so 2 du is equal to u dx. Is this correct? Yeah, I think so. So dx is equal to 2 du over u. Then I've got the integral of 1 over u squared minus 1 under a root times 2 du over u. This looks like there's a trig thing, or a an inverse trigonometric antiderivative. Like, what is this? Is this secant inverse or something like that? Okay, let's do a little bit of rough work. I know the derivative of secant is secant times tangent. I'm missing a y prime here for chain rule, so I've got y prime is equal to 1 over secant y tan y, and secant y is x, and tan y, what is the identity? Tan squared y is equal to 1 plus secant squared y. No, that's not right. It's sine squared plus cos squared equals 1. Let's divide both sides by cos. We get tan squared plus 1 is equal to secant squared. Okay, so tan squared y plus 1 is equal to secant squared y. This, I believe, will help us, because now we have tan squared y is equal to secant squared y minus 1. Yeah. So tan y is equal to the square root of x squared minus 1. Okay, so let's put things together now. Let's put it all together. Starting from the top, we've got 1 over e to the x minus 1 square root. I'm going to let u squared be equal to e to the x. So 2u du is e to the x dx. So 2u du is u squared dx. So dx is 2 du over u. And now substitute everything into the integral. I get 1 over u squared minus 1 square root. Factor of 2 comes out. I've got another 1 over u here. And this is equal to, as we just showed, secant inverse of u plus a constant. So we end up getting 2 secant inverse of e to the x over 2 plus a constant. Cool. And let's check our work. Let's take a derivative of this. And make sure we get the original thing. Okay, so f prime is 2. I'll do the chain rule part first. So we have an e to the x over 2 times a half. And now we need to multiply by the derivative of secant inverse evaluated at e to the x over 2. But we did that earlier, right? The derivative of secant inverse is this thing here. So I have to replace x with e to the x over 2. So I'll write this as 1 over, we had a 1 over x, so it's 1 over e to the x over 2, times the square root of x squared minus 1, but we're replacing x with e to the x over 2. So squaring it turns it into e to the x, and you see that we get everything canceling that we want. So f prime of x is 1 over e to the x minus 1. Yeah, so this works. There's our antiderivative. Yeah, this was kind of a weird one. My first instinct was wrong. You know, I guess in the back of my mind, I was thinking that difference of squares would allow us to get rid of the square root sign somehow. I'm not really sure where my instinct to turn this into this inverse trig thing came from. I mean, this was almost it, right? Like we didn't quite make the right substitution there. We wanted u squared to be e to the x, but this sort of rang some bells of familiarity, I suppose. So it kind of led me into the right track. Thanks for watching.